Hello everyone, so this is lesson number 10 of our trigonometric identities unit. I'm going to start looking at solving trig equations, particularly linear trig equations today. So to start off, we're going to look at solving our double angle sine of 2 theta equals 1/2. And that'll be on kind of our standard interval of 0 to 2 pi. Theta has to be between 0 and 2 pi. If we were to graph this out, this is a regular sine function, except it has a horizontal compression by a factor of 1/2. So everything is going to be shrunk by 2, which means we have a period of pi. So we need 4 sections within that period of pi. I guess I put that 7 units. It's a little harder. This won't be exact, but pi over 4, pi over 2, 3 pi over 4 are going to be our key points. For sine, we start at the axis symmetry. We go up to our maximum point, down to our axis again, down to our minimum point, and back to our axis, and then we would continue again. So this will be 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi, and we'll do the same thing again. We're going to go up to the max, back to our axis, down to the minimum, back to the axis. This is a pretty rough sketch, but we can see this sine of 2 pi looks something like this. So we want to see how many times does it go through 1/2? How many times is sine of 2 theta equal to 1/2? Well, if this is 1 and -1, we're going to go through 4 times. We need to find our reference angle. Sine of 2 theta equals 1/2. So 2 theta is going to be sine inverse of that 1/2. If we remember our special triangles, the inverse of sine half, that happens at an angle of pi over 6. So 2 theta has to be pi over 6. Divide both sides by 2. And we get theta equals pi over 12. So theta, one possibility of our sine function going through 1/2 is at pi over 12. Also, pi over 12 before so this function is sine of 2 theta. So our 2 times theta, this is our pi over 6 here. We're going through 1/2 at pi over 6. So that's that first quadrant. So our related acute angle is pi over 6. And then we used that related acute angle to find what theta was. Another related acute angle, or another angle where this was positive, is pi over 4, pi over 2 So our angle theta here is pi over 6. Right here, another 2 theta is pi over 2 minus that angle minus that theta, pi over 6. Pi over 2 minus pi over 6. That's not right. Oh, that was right. The next 2 times that we can equal 1/2, we can add 1 full period to both of our previous answers. So our first one was 2 theta was pi over 6. If we add our period is pi to that, we get 7 pi over 6, and that is 2 theta again. So we need to divide both sides by 2. 7 pi over 12 equals theta. And we do the same thing adding a period to our 5 pi over 12. Sorry, to our 5 pi over 6, because this is our sine of 2 theta. So we add a period to 5 pi over 6. We add pi, we get 11 pi over 6. That again is 2 theta. So that means theta would have to be 11 pi over 12. So we have 4 different angles. We have theta can be pi over 12, 5 pi over 12, 7 pi over 12, and 11 pi over 12. Sorry, I realize we should be adding to theta. This is a theta, like theta f of theta graph. So we should be adding to our thetas instead. So it should be pi over 12 plus pi, which would give us 11 pi over 12 is theta. And 5 pi over 12 plus pi is 17 pi over 12 equals theta. So that's just going to change these last 2 to 13 pi over 12 and 17 pi over 12. This graph is of theta, not of sine of 2 theta. Originally, we needed to divide by 2 to get our thetas that show up here. This is a pi over 12. And then because this graph is of theta, we already have theta. We just need to add our periods to those thetas. So I apologize for any confusion there. But this would be our answer here. And we're going to look at the next example now. Solve sine of theta over 2 equals -1 for 0 is less than or equal to theta is less than or equal to 4 pi. So again, this is from our original parent function of sine of theta. This is now going to have a vertical stretch, a horizontal stretch by a factor of 2. So if we draw, let's use a ruler this time. If we draw our function, from 0 to 4 pi, we're stretching it by a factor of 2, so it's going to take 4 pi to complete one cycle. And a quarter of that, so every pi is going to be one of our key points. So we start at 0, go to our maximum value, back to the axis, minimum value, back to the axis. So our shape here, so we can see this time we're only going to have one scenario where our function's equal to -1. And we can show this algebraically. Sine of theta over 2 equals -1. So theta over 2 is going to be the sine inverse of -1. From our exact trig functions, so we talked about special triangles, but also what happens at sine of pi over 2, cos of pi over 2, sine of 3 pi over 2, and so on. Sine is equal to -1 when the angle is 3 pi over 2. So theta over 2 equals 3 pi over 2. Multiply both sides by 2. If we multiply that by 2 and that by 2, our 2's cancel out, and we just get left with theta is 3 pi. And that's what showed up here in our graph as well, that theta had to be equal to 3 pi. We'll look at same function, sine of theta over 2, but this time for -√3 over 2. And that is also for 0 is less than or equal to theta is less than or equal to 4 pi. We already drew out our graph. We can see -√3 over 2 is somewhere in between 0 and 1. It's going to go through twice. Those are very approximate locations. But at least we know it has to go through that, wherever that -√3 over 2 is, has to go through that twice. So we know we're looking for two different answers. So if we look at sine of theta equals -√3 over 2, our special triangle that is important for this one was our √3, our √3, 2, 1 triangle, which had a pi over 6, a pi over 3, and a pi over 4, pi over 2 angle. Sine of -√3 over 2, sine, that's our opposite over hypotenuse. √3 over 2, we're looking at pi over 3. So our related acute angle, our theta r, and in this case, because it's sine theta over 2, we're looking at theta over 2, the related acute angle of that has to equal pi over 3. Where is sine negative? Sine's going to be negative in the third quadrant and the fourth quadrant. So to get to the third quadrant, that is pi plus our related acute angle of pi over 3. And that is going to be equal to theta over 2, because we're looking at sine of theta over 2. So 4 pi over 3 equals theta over 2. Multiply both sides by 2, and we get 8 pi over 3 equals theta. And for our fourth quadrant, going all the way here. That is 2 pi minus pi over 3 is going to be our theta over 2. So 5 pi over 3 equals theta over 2. And that would be 10 pi over 3 equals theta. Our next example, we have cos of theta equals cos of 3 theta over 2 equals negative 1 over 2. And we're looking at from 0 to 2 pi. So first thing we're going to do again is we're going to sketch our function 3 theta over 2. That's going to have a horizontal compression of a factor of 2 over 3. So our regular period is 2 pi, but this is getting compressed by a factor of 2 over 3. So our new period is 4 pi over 3. So a cos function starts off at the maximum. So after a full period, it's going to end off at the maximum. And for that period, we need to divide it into 4 for our key points. So 1/4 of the period, pi over 3, we get down to our axis symmetry. Halfway, 2 pi over 3, we're at the minimum. 3/4 of the way at pi, we're back at the axis. And then after a full period, we reach the maximum. Because we need to go to 2 pi, we're going to continue that same pattern. We can see 2 pi is going to end up being a minimum. And we can draw a rough graph and see what this is going to tell us. So we're interested, when is this equal to -1/2? Well, it looks like there's going to be 3 different answers we're interested in. So we need 3 solutions. So cos of 3 theta over 2 equals -1/2. We're going to be interested in our once again our pi over 6, pi over 3, pi over 2 triangle. And so cos is adjacent over hypotenuse. So our related acute angle of this 3 pi over 2 is going to be again pi over 3. We don't care that this is negative or positive. We can worry about that after. Cos is negative for the first time in the sine quadrant. So this angle here, that is pi minus our related acute angle, and that has to equal this 3 theta over 2. So 2 pi over 3 has to equal 3 theta over 2. can multiply both sides by 2 and divide both sides by 3, and we get theta is 4 pi over 9. We can do the same thing and look at the next quadrant. That cosine is negative, which is the third quadrant. So it's now pi plus pi over 3 equals 3 theta over 2. Pi plus pi over 3 is 4 pi over 3 equals 3 theta over 2. Multiply both sides by 2, we get 8 pi over 3. Divide both sides by 3, we get 8 pi over 9 equals theta. So we get our first two solutions, and that makes sense. Our first one is a little bigger than pi over 3. The second one is just less than pi. That sounds okay so far. And now because our third solution is just in the next period, we can add 1 period to our first answer. So our first answer was 4 pi over 9, and we're going to add what our period was, which was 4 pi over 3. So in order to get the same common denominator, we need to multiply the second fractions top and bottom by 3, and we get 12 pi over 9. And so theta has to be 16 pi over 9. And that gives us a third answer less than 2 pi. So all three answers are within that range. I believe we got one more here. We're going to look at a little more complicated example now. We're going to solve solve 2 sine theta cos theta equals cosine 2 theta. So we're not just looking for a trig function equal to a number anymore. We need to do a little bit of work. 2 sine theta cosine theta, that is the same as sine 2 theta. We can use that sine double angle formula to help us there. And so really this equation is the same as sine 2 theta equals cosine 2 theta. If I divide both sides by cosine 2 theta, sine of something divided by cos of the same thing equals tan of 2 theta. Cos 2 theta over cos 2 theta is just going to be 1. So we can use these different trig identities that we've learned to solve a more complicated expression and turn it into a simpler trig expression that we know how to graph. So this is a tan function with a horizontal compression of a factor of 2. So we're going to draw, we're looking for the interval from 0 to 0 is less than theta is less than or equal to 2 pi. So our regular tan has a period of pi. This tan function is going to have a period of pi over 2. And so we need so tan starts at the origin which means if it has a period now of pi over 2, because it's half of the original period, it's also going to be at the x-axis at pi over 2. And in between, it's going to have a vertical asymptote. It crosses through 1 halfway to that vertical asymptote, and then -1 halfway to the next x-intercept, and it repeats that pattern. So we're interested, when is this function tan of 2 theta, when is it equal to 1? So we should have 1, 2, 3, 4 solutions to this problem. We're going to do it the exact same way we've been doing our other ones. So tan of 2 theta equals 1 if we look at our pi over 4, pi over 4, pi over 2 triangle, special triangle. Tan of pi over 4 is our related acute angle. So the first quadrant that tan is positive is our first quadrant. That angle there is going to be 2 theta. It's going to be pi over 4. Multiply both sides by 2. Theta is pi over 2. Sorry, not multiply. Divide both sides by 2. Pi over 8. Now for tan, each of these points is exactly 1 period after the previous one. So because our period is pi over 2, we can just add the period to the next one. So theta, our next theta is going to be pi over 8 plus our period plus pi over 2. So that is pi over 8 plus 4 pi over 8. So theta equals 5 pi over 8. Our next one, we're adding that period again. 5 pi over 8 plus pi over 2, or plus 4 pi over 8. And we get 9 pi over 8. And our last one, we're going to add another 4 pi over 8. And we get 13 pi over 8. There we get our 4 different answers. And we can see pi over 8, that makes sense. That was exactly halfway between 0 and pi over 4. 5 pi over 8, that was exactly between pi over 2, 3 pi over 4. That makes sense from our graph. So that's the end of this lesson. This may be a little weirder, especially that our related acute angles are no longer just theta. We have items with double angles and half angles and anything else in between. So if you have any questions, please let me know. But other than that, enjoy the rest of your day, and you'll hear from me again soon. Goodbye.